The read part of the CRUD functionality of our app is done. We have, after all, implemented watching the notes in the previous part. Now it's time to finish up the Node repository with create, update, and delete methods. Hello, welcome to ResoCode, where we are getting prepared for real app development so that you will get freelance clients or a job and be confident about the apps you build. So subscribe and hit the bell to join us on our quest for becoming in-demand Flutter developers. So this particular part of this domain-driven design Flutter series will be quite short. That's because we have just 3 methods to implement, and they don't conceptually belong to any other part. I cannot combine it with the next part where we are going to, for example, implement the form block. So that's why this part will be a bit shorter than usual. We're going to implement the infrastructure layer for editing the nodes. That means the update method on the node repository. So that will be the method for updating the node with new data like this, changing the color to something like pink. Boom. The update method is run, and this is what happens. The data on Firestore will be updated through the use of our node repository. The same goes for the method create, where we can create a new node together with to-dos, which cannot be empty, of course. And a new to-do will be created, of course. And lastly, we're going to implement the delete method for deleting to-dos. So let's get right to it. We are going to just write code in the methods which we have created an interface for in the previous parts. And let's start off with the create method. So we already do have previous methods which we have implemented. Those are watch uncompleted and watch all. In all of them, we get the user document at first, and we are going to do the same thing, of course, when it comes to creating or updating or deleting nodes. That's because we still have to access the nodes for our particular user who is currently signed in. So that's why we still do need to get the user document. However, there are also big differences when it comes to creating, updating, and deleting and watching nodes. That's because watching nodes happens via the stream interface, via the real-time aspect of Firestore. So we are operating with streams, we are mapping, we are handling exceptions in a certain way. When it comes to creating nodes, that's just a one-off operation. So we're going to use regular try-catch blocks and so on. So let's get right to it. The first thing we want to do in the create method is the aforementioned try-catch block. It's going to wrap around our whole implementation of this method. For now, let's just provide a catch-all statement. We're going to refine it further on, or later on actually. Something like this, catch. And the first thing is the copied user doc getting extension call. This is the user document extension on Firestore, which we have created in the previous part. And we of course want to make all of these functions asynchronous. So let's just copy the async keyword. Create, delete, and update are all going to be async. And let's actually move the update method to be above the delete method. And now the interface of the create method says that we are going to receive one node entity. But of course, we are in the infrastructure layer now, as you can see in the node repository.dart, which lives in the infrastructure layer. And when we want to write something to Firestore, we first need to grab its data transfer object. That's because we cannot just write the node body to Firestore. No, node body is represented by a string, and only this primitive data representation of a string can be written to Firestore. And that's what we have created our data transfer objects for a few parts back. So we need to grab hold of final NoteDTO, and we are going to set it to be equal to NoteDTO dot from domain and convert the note, which is being passed in from domain to NoteDTO. And now we're just going to use the standard way of writing to a Firestore document. So we want to say user doc, which provides the document reference to the user document, of course. And then we could again say collection notes, but we can also use our custom extension, which we have created in the previous part with the name note collection. And then to create a new document in this collection, we can either say add and provide the data, which would be NoteDTO to JSON. We could do something like this and it would absolutely work. But the thing with our implementation of the app is that we already have IDs, which are being unique, already generated. If we take a look at the note entity, we can see that creating an empty note or creating a note in general, the ID is represented by a unique ID. So we know that we already have an identifier created, and we would like to persist this identifier sort of in Firestore 2. We do not want to create a new identifier for Firestore. We still want to keep this locally generated identifier also in the remote database. And as you may already know, the add method, which the Firestore client library provides, returns a document reference with an auto-generated ID. And as I said a while ago, we do not want to auto-generate the ID just for Firestore specifically. That is because we have already auto-generated an ID at the time of creation of our note entity. So that's why we're not going to say add. We are instead going to say .document, select a document, which will be located in our case at the location of NoteDTO.id, and then instead of add, we are going to say set data. And what this is going to accomplish is that a new document with the ID of the notes ID will be created. Because whenever set data is called on a non-existent document, that document will be created. If set data is called on an already existing document, that data will be overwritten completely. So that's what we are doing. And also set data is an asynchronous operation which returns future void. So we are going to just await the execution of the set data method. And if nothing happens inside this try catch block, inside this try part of it at least, we're going to return write and unit, because that's what the interface of our method says that we should return. All right, so this is quite self-explanatory. We are using the document method so that we can provide an ID of our own. And what are we going to do inside the catch part of the try catch block? Well, we are going to handle exceptions very much like we do inside this onErrorReturnWith method, which comes from RxDart, which we have implemented in the previous part. So again, we only want to sort of react, we only want to catch platform exceptions, because only platform exceptions can be actually thrown from the Firestore client library. So we're going to say on platform exception catch, and we're actually going to catch E, let's give it a name. And now, if e.message contains permission denied, so let's just copy that from above, then we still want to return left insufficient permission. So let's just copy everything from over the watch uncompleted method, okay? Still, we are just converting exceptions to failures, which we return through the either type. And otherwise, so again, else, we're going to return note failure dot unexpected. So again, permission denied just means that the security rules do not allow the currently signed in user to access the particular document. This should actually never happen in our app, but still we are handling this case just to be safe. And then unexpected, well, it speaks for itself. If something very weird happens, we are just going to return left unexpected. Okay, so this is it for create. And as you can probably imagine, the update and delete methods are going to be very, very similar. So we are not going to do any kind of a special refactoring when it comes to these methods. We're mostly just going to copy and paste their implementation. That's because there are going to be enough changes that refactoring is not that simple, and in my opinion, doing some extraction of the duplication would actually create a complete mayhem. The code would not be readable, so we are probably better off in just copying and duplicating the code a bit. That's because the duplication is not really that humongous in this case. So let's just copy the try-catch block from create. And actually, I have also noticed that I have accidentally moved the update method to be nested inside the create method. So let's just select it and move it down outside of the bracket. All right, now we are talking. And let's just paste the create implementation here. So we still want to get the user doc, convert the node entity to a data transfer object. And then the basically only change we want to do here in the try block is that instead of set data, we're going to say update data. We could just as well leave it at set data. It would most likely, or actually it would 100% work here. But just to be safe, basically the difference between update data and set data when it comes to Firestore is that, let's say that the data which we do have on Firestore contains something like, let's provide a block comment here actually. And the data which we are trying to push to Firestore looks like this. So as you can see, the data which is already on Firestore has 2 fields, but the data which we are trying to push to Firestore has only 1 field. What would set data do? Set data. What would happen is that the data on Firestore would be completely overwritten. That means that the field 1 would be deleted, and only the field 2 would remain on Firestore, and it would hold the value 42, because that's the data which we are trying to push over there. However, in the case of update data, what would happen? So update data, what we want to happen is that only field 2 will be updated to 42. And since field 1 is not present in the JSON we are trying to get to Firestore, field 1 will remain untouched. So that's what we are doing here, in case you didn't know the differences between update data and set data. Update data is just not going to override anything. And in addition to handling permission denied and some sort of an unexpected exception, there is one more thing that we should handle, and that is not found. So we're going to copy this initial if statement, we're going to say else if not found happens, then we want to return note failure, something like unable to update. Not found simply means that the document which we point to could not be found. And since we are not setting data, we are just updating data, this document ID has to already be present inside Firestore. So in the rare occasion, which again should not even happen in our app, that we want to update a document which does not exist, then we are going to handle it gracefully and return a note failure unable to update. So let's actually go over to the note failure union, and we are going to create such a union case. So let's just say unable to update, and again unable to update with capital U, and let's run our favorite command. So that is flutter pub run build runner watch delete conflicting outputs. Okay, while this is running, we can come back and we have just implemented the update method of our Note repository. So what comes next? Well, of course, the thing that comes next is the delete method. And again, let's just copy the create method implementation. We're again going to have a try catch block here, get the user document first, but the difference is that when we are deleting a note, we still receive the full note, but we actually do not need to know about its contents. We just need to know about its ID. So instead of getting a full-blown converted note DTO, we're just going to get the note ID, and we are going to get it from note entity. No need to convert anything to DTO right here. So note ID and then get or crash, which is going to grant us the string representation of our unique ID. And then it's just pretty simple. We're just going to say user doc note collection notes ID, and we're going to say delete. And again, if everything went smoothly, we're going to return right. Otherwise, we're just going to catch these errors right here. And actually, we should most likely, I think, catch the not found platform exception too, because technically when we are deleting something from the database, it can also happen in an unfortunate way that the thing which we are trying to delete has already been deleted by some magical spells. So we still need to handle the case where the document we are trying to access or delete in this case is not found. All right, and that's it for this short part of the domain-driven design Flutter series, where we have implemented just 3 methods: create, update, and delete of our Note repository implementation class. In the next part, we are going to implement the Note form block, which will be a block responsible for the Note form, of course. So we are going to handle things in a very similar way in how we handle the sign-in form, but it will be a bit more complex because, of course, sign-in form holds just the email and password fields, but the Note form block needs to take care of the to-dos as well, which are very specific in how we are going to handle them. So you have something to look forward to for the next part. So be sure to subscribe to this channel and also join the notification squad to make sure you grow your Flutter skills, because here on ResoCoder, I am determined to provide you with the best tutorials and resources so that you will become an in-demand Flutter developer. And if you are serious about becoming a great Flutter developer who can build real apps for clients or at a job, go to flutter.education, link is also in the video description, to get the top curated Flutter news and resources aimed at improving your app development career. Over there you can also subscribe to my mailing list to get the best Flutter resources delivered weekly right into your inbox. If this video helped you, give it a like and also share it with other developers who are surely going to find it beneficial too. Leave a comment if you have anything to say, and see you in the next video.